The last topic I'm going to cover is something called recursion. Recursion is a function that calls itself, which acts like a loop. So a simple example of what we can do is calculating factorial. Let's write 5 factorial. To calculate a factorial of a number, you need to multiply every number from 1 up until that number. So for example, factorial 5 would be 5 times 4 times 3 times 2 times 1. And this will equal to 120. So this is 5 factorial. Now if we had 6 factorial, it would be 6 times 5 times 4 times 3 times 2 times 1. And that's equal to 720. This is a typical example of what we can use recursion for. So let's write out our recursive function. Int, let's call it factorial. We'll take in an integer n. So basically what we want to do is we just want to return n times our method, which would be n minus 1. So when we first call this, it will hit the return line of, for example, if we pass in 6, it'll be 6 times factorial, which would be n minus 1. So it would be 6 times 5, and then it'll run the function with 5 times n minus 1, which is 4. And then when it runs for 4, it'll be 4 times n minus 1, which is 3. So it'll basically keep writing this out until we hit a base case. We currently don't have a base case, so let's write one. In this example, our base case would be, well, n is equal to 1. And what we can do is just write return 1. So when we eventually get to 2, it'll be 2 times n minus 1. And then when it hits 1, it'll say n is equal to 1, return 1, and then it'll do 1 times 2 times 3 times 4 times 5 times 6, and it will return the result of the factorial. So let's run this. Let's do print f. We'll do factorial of 5 exclamation mark is %d. And then for %d, we can actually use the method factorial to satisfy the print function here. So we can just do factorial, and let's pass in 5. Close up the print statement, Control F5. And as we can see, factorial of 5 is 120, and 6 would be 720, so let's update it, make sure it works. 6, Control F5, 720, perfect.